This is the mock test paper you should solve before going to the examination. Okay, you have to solve these 30 questions to check where you are. And there is a reason why I'm releasing this mock test paper at last, because these are having some tricky questions and some lengthy questions. If you could able to solve it in 45 minutes at max, then you can easily solve your question paper on your real examination. Okay, so let's get started with the first question. A cell is represented by this, and the E cell value is given, that is 298 Kelvin, and they are asking for pKa of the weak acid. Okay, look at the reaction. It's a bit different from what usually we see in electrochemistry, right? We have HA, NAA with H2. But what is the real reaction happens over there? Anodic part, the reaction would be zinc, right? Zinc, anode means what will happen? Oxidation. So zinc will lose the electrons to form zinc 2 plus, 2 electrons it will lose. Similarly, as a cathodic part, what will happen? Here I have acid. So 2H plus 2 electrons, it will release H2 gas, right? So first let's find out E naught cell, which is equal to E naught cathode minus anode. Substitute the values. Here I have, this is in platinum electrode, standard hydrogen electrode, right? So which is 0, and for zinc that is given as minus 0.76. So minus of minus 0.76, the answer would be plus 0.76 volts. Okay, now let's substitute it in the Nernst equation. So here they have mentioned the pressure also, temperature also. So accordingly we have to put the Nernst equation, E naught cell minus 0.0592 by N log of zinc 2 plus concentration into pressure by our H plus square, right? 2H plus is used. Now let's substitute the values. E cell value is given as 0.464. So 0.464 minus 0.0592 by 2 electrons log of zinc 2 plus concentration is given as 0.1, right? 0.1. And the pressure is 1 atm divided by H plus concentration. I don't know, I have to find it out. So upon solving this one, E cell value that we found out just now, that is plus 0.76. Okay, so upon solving this one, you will get H plus square, that would be 10 to the power minus 11. So from here, what would be the H plus? H plus is 10 to the power minus 5.5. How can I take log for this? No need to take log. Just find out pH. So what would be the pH? If the H plus concentration is this much, the pH would be the upper part, right? So which will be 5.5. If the pH is this, what they are asking? They are asking for the pKa value. So just use the formula to find out pKa, which is equal to, we can use pH is equal to pKa plus log of A minus concentration by HA concentration. Substitute the values, which is 5.5, and pKa I don't know, plus log of A minus concentration. What is A minus over here? NAA, right? That is 0.1 molar, and HA, that is 0.1 molar. So both are 0.1. So whole term, log 1, that is equal to 0. So pKa plus 0, which is equal to 5.5. So pKa is equal to 5.5. Okay, bit lengthy question, but you have to do it fast. Okay, so that is the answer to this one. The next one, here I have a complex of AA2 A2 type, right? En is a bidentate ligand. Which of the statements are right or wrong? The first one, the complex exhibit both geometric and optical isomerism. That is true. We already released a 10-second trick to remember which are all having this isomers. So this is true. And CFSE of this one is higher than the CFSE of this, because En being the strong field ligand. Yes, that is also true. And this will take up in tetrahedral geometry. So many times you must have solve this problem. Right, this question should not take more than 30 seconds. That also for reading those question. Then the trans isomer is optically active, has a planar symmetry, while the cis isomer is chiral with two non-superimposable mirror images. That is also obviously true, optical isomers. Then chelate effect makes this one is more stable than the another one because of entropic reason. Yes, chelation will give you the more stability. So all are right statements. Okay. Then moving on to the next one, look at this question. 2R3S, 2-bromo, 3-methyl pentane. We are highly expecting this kind of question. Because question will look scary. So that by reading the question, you will not try to solve it, or else you will panic. Okay, that's what they want. So look at the question. They have given the big name is treated with alcoholic KOH. Of course, that is an elimination. I have mentioned also that is elimination. But always remember, alcoholic KOH means elimination, aqueous KOH is for substitution. The substrate has the following Newman projection, citing along C2 to C3 bond in that anti-periplanar conformation of E2. Okay, so elimination happens. What is the major product and the correct stereochemical reasoning for that? Okay, that is what the question is. I already told you this kind of elimination happens at the anti-position because I have, look at this texture, 1, 2, 3, 4, pentane. In third position, I have methyl. In the second position, I have bromo. So anti-elimination will happen over here. So if that is happening on anti, so what would be your product? Right, the product will be on the anti only, I mean opposite only. Right, so which should be our answer? Option 1 says E and option 4 says E. And 1 says as the major phase of product via anti-periplanar elimination. And the 4 says major product because anti-periplanar H leads to E geometry. Okay, so which one would be our answer, which is very closest? Which is option E. Right. And option 4 seems also right statement. I'm not sure they're asking for both the ones or not, but E configuration that would be formed. Okay, anti-elimination happens over there. Then the next one, for the gaseous equilibrium at 298 Kelvin, delta H, delta S values are given. A vessel at 298 Kelvin has an initial pressure of 2 atm of pure N2O4. At equilibrium, degree of dissociation alpha is 0.20. Right. These 30 questions now, I'll be attaching PDF. We are not going to solve all 30 questions now. You can check out a question with the solution. Make sure that you are attempting the test as a test. Okay, you are not going through the papers. You are going to write the test. Okay, so we are highly expecting these pattern of questions. Okay, all 30 questions are highly expected. And 4 statements are given over here, which are all correct. That's what the question is. Okay, first of all, let's solve this one. What they are asking? Delta H value is given, delta S naught value is given, P initial, that would be 2 atm, and alpha value, degree of dissociation, that is 0.20. So let's find out how much N2O4 will be remaining. N2O4 gives 2NO2. Right. If at the equilibrium, that is 0, at the initial stage that would be 0. At the equilibrium, what happens? It will form, since alpha is 0.20, N2O4 remaining would be, that is 1 minus alpha, so which is 0.80. And NO2 formed, there are 2 NO2s are formed. So 2 into alpha, that is 0.40. So what would be the total moles? Total moles equal to 0.80 plus 0.40, which is 1.20. Right. Similarly, if you find the partial pressures of N2O4, then Out of 0.10, I have 0.40. Sorry, for N2O4 that is 0.80. Then that would be, the pressure is 2, right? Pressure is 2, so which is 1.3. Similarly, for NO2, that is 0.40 by 1.20 into 2, that is 0.66. Okay, now let's find out Kp. Kp is equal to 0.66 by 2 NO2, right? To the power 2 by 1.33, which would be 0.33 atm. Okay, so what we are going to do is just check any Kp terms are involved over here. Kp at 298 Kelvin, if you substitute this, you are getting 0.33. That is true. And delta G naught at 298. Okay, so if you find this, other things will fall into the place. Right, statement 2, which will also be right. What about statement 3? The reaction is non-spontaneous at 298 Kelvin under standard conditions, but becomes spontaneous above T is equal to delta H by delta S. So if you substitute the values over here, delta H by delta S, what will you get? This is 56.9 kilojoules. So 56,900 by, this is 175 joules. Okay, so which will get it as 325. Yeah, that is also true. And statement 4, increasing pressure at constant temperature shifts the equilibrium left and decreases the alpha, but Kp remains unchanged. Yes, obviously, if I'm increasing the pressure, what will happen? Equilibrium will shift to fewer moles of gases. So which means that will shift to reactant side, shift to left. And due to that, what will happen? The dissociation will get decreases. But Kp remains constant. Yes, that is also true, because that is a function of temperature. So that will remain unchanged. So all 4 statements are right. Then the next question, consider the following series of reactions involving phosphorus compound. Okay, the reactions are given. Which combination of statement is entirely correct? Okay, the reaction A, phosphorus is oxidized from 0 to +1 and reduced from 0 to -3. It is a disproportionation reaction. Okay, it's a simple question, but all you need to do is you have to do the calculation very carefully. Don't do any silly mistakes to find out the oxidation state and compare with the statements given over here. H3PO2 has 1 pH bond and this is monobasic. Is it true? How many pH bond that has? It has 2 pH bonds, right? It's not monobasic. That becomes incorrect. And what about statement 3? H3PO2 undergoes, this is right, this is incorrect, and H3PO2 undergoes disproportionation from phosphorus +1 to 3 and -3. That is also true if you find out the oxidation state. And PCl5 exists in this state in solid state, and P is sp3 dehybridized in SpCl5. That is also true statement only, we know that, right? So you have to do it carefully. That is what they want. Either they will give you lengthy calculation or questions will be lengthy to read. That's how you can they can twist you. In the next one, a solution of benzoic acid in benzene shows osmotic pressure. 0.610 gram of benzoic acid dissolved in 100 ml of benzene solution gives pi is equal to 0.0492 atm at 300 Kelvin. Separately, 0.244 grams of benzoic acid dissolved in 50 grams of benzene shows this much. Using both the experiments, determine alpha value and the Van Hoff factor. Okay, usually they will be asking about the temperatures or the TF value, right? But they have twisted this time. Can you pause the video and write down the answer to this question? It should not take more than 1 minute. Just try it. Okay, so let's quickly solve. First of all, they have talked about the osmotic pressure. So what we know is pi is equal to CRT. So C, I'm taking it as N by V. So nRT by V. So which will give you the observed molecular mass. So which is weight RT by pi V. Substitute the values over here. So what are the values given? Weight, that is 0.610, and R value 610, R value that is 0.082 into 300 divided by pi value, and the volume is given as pi value they have given in ATM 0.0492 ATM and 100 ml of benzene. So 0.0492 into 0.1. So which will give you essentially the value as 244 gram per mole. So what they have given is mass is 122 gram per mole. So from here you can find out alpha, that is you can just do to find M actual, that is 122, and then what we found, that is 244. So what would be the dimerization? How much that have happened? That would be 0.5, right? Which means it completes the dimerization. It shows the complete dimerization. Okay, so that is sorted. The next one is, next is it will be involving with freezing point. So freezing point, we know the formula of delta TF is equal to I KF M. M is equal to substitute the values. So that is 0.244 by 122 divided by 0.50, which will comes out to be 0.04. So the I value, M value is sorted, and if I want I, then delta TF by KF into M. So delta TF benzoic acid 50 grams of benzene, delta TF is 0.124 by KF value, that is 5.12 into 0.04, that is my M. So if you substitute this, you will be getting 0.606. So now 0.606, that is my I value. You can take it as 0.61. So M observed from here, that is 122 by 0.61, that is 200 gram per mole. Look at the options. Once you solve the question, you can look at the option and check which option gives you the right answer. This is almost the problem. What else they are asking in the options? 0.61 from both experiments. Alpha is equal to 78. Okay. So what you can do? I value, that will be 1 minus alpha by 2. Just substitute the values. If I value, that is 0.61, then what would be the alpha? So alpha you will get as a 78%. Okay, that's how the that is all the whole calculation is about. You can check the answer. Then the next one, identify the final product when the following sequence is carried out. Step 1, acetaldehyde with HCHO. Okay, gives product A, and product A with concentrated NaOH and heat gives product B. Product B with H3O plus gives product C. Final neutral product. Okay. First of all, this is having alpha hydrogen and this is not. Reacting with concentrated NaOH at 0 degrees Celsius. So what is this reaction? This reaction is that the alpha hydrogen part can undergo enolization to form a cross aldol condensed product. It's not a condensed product because I have the temperature of 0 degree. Okay, it's not give it will not give you the condensed product, which will give you because we are using excess of CH3CHO. So again and again it will react to produce CH2OH with CCH4. Okay, so that is our product A. Product A with concentrated NaOH. You can understand the product A, right? If that is not clear, please let us know. And product A with concentrated NaOH. So that is the Cannizzaro reaction. So that will give you, so look at the product A. I don't have any alpha hydrogen. That with NaOH, that is giving us product B. The B can be, actually Cannizzaro will give you two products, right? It will give you alcohol and as well as the carboxylate. And look at the step 3. B with H3O plus gives a product that is a final neutral compound. Okay, so if it is forming a neutral compound over there, what must be a B? Okay, so let me write it over here. CH2OH, 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 and this is HCHO, which will undergo, this is product A, which will undergo Cannizzaro reaction to form the product of CH2OH. The other things will remain intact. OH, and this is OH. Along with that, I'll be having HO minus. What you can do is look at your options, and option D, this is not possible, right? So from the first step itself, it's not possible. And option B says 3-crossed aldol reaction. After that would be product A. It's not product C, right? So that is not possible. And product C is a 3-crossed aldol plus Cannizzaro. That would be possible. And product C is this one from single aldol and reduction. No, that is not possible. Okay, so it's in process which involves in Cannizzaro, the step 3 I'm talking about. Okay, and the next one, an electron in a hydrogen atom undergoes a transition. The following data is given. Transition emits a photon with lambda 97.23 nm, and after emission the electron is in state NF. The separate experiment, the electron accelerated through V volts through 3 Broglie, lambda is equal to 0.1 nm. The uncertainty in position of the accelerated electron, that is delta x, is equal to 0.05 nm. Okay, they have given these data and the statements are also given. Okay, so we have to find which is right and which is wrong. First of all, the first statement involves the transition from n is equal to 4 state to n is equal to 1 state, that is Lyman series. So if I am substituting the value RH is equal to 1 state to 4 state, no, so 1 by 1 square, that is 1 by, so if you substitute it, the lambda value you are getting as 97.2. So if I am adding 4 square, that is 16, by substituting the RH value, you can do this one in two different ways. Either you can keep this value as unknown, n value as unknown, and find out the lambda value, or you can, by substituting the lambda value, having n value as unknown, or substituting the n value, find out lambda value. Okay, if you do that way, you will get as the same one. So that's all you have to do. And second one, the minimum delta P of the accelerated electron, that is this. So for this one, what you can do, we know that delta P minimum equal to h by 4 pi delta x, right? So substitute the value 6.626 into 10 to the power 34 and 4 pi into delta x value. They have given h by, okay, this is comes out to be this. Okay, so if you substitute these values, what is the x value given? X value is 0.05. 0.05. So by substituting this, substitute the pi value and you should end up with this one. Okay, so that is what the question is. You will get almost this. Then accelerating voltage V is equal to 150.6 from this one. Okay. So here also you just need to substitute the values to find out it. So this kind of questions we can expect because this involves a lot of solving and you have to solve it very quickly. The answer to this question becomes 1, 2, 3 are right and 4 becomes the false statement. Okay. Then the next one, arrange the following in the decreasing order of basicity, that is the first part of question. Then identify which compounds undergo Hofmann bromide degradation cleanly. Additionally, which amine cannot be prepared by Gabriel Thalhamide synthesis. 3 parts are involved over here. Okay, so first of all, you have to arrange it in the basicity order. That is your first goal. If you are sure about these 2 things, let's find out using that one. Which undergoes the Hofmann bromide degradation cleanly. Okay, so Hofmann bromide degradation is for amides, right? Amides to give you the primary amine. 6 molecules are given which will not undergo any Hofmann bromide degradation. So which is right? And which cannot be prepared by Gabriel Thalhamide. So Gabriel Thalhamide synthesis is for again a primary amine. So look at this one. Aniline, para-nitroaniline, cyclohexylamine and pyridine, piperidine, methoxyaniline, these are aryl amines, right? So which makes this as your right answer. Don't panic by seeing the question. If you able to solve it, okay, but don't panic, don't lose your marks by panicking. Okay, so coming back to the decreasing order of basicity, I'll give you the trick. Like if you see the nitrogen atom which is having a lone pair that is ready to donate, okay, so then that would be large basic. Okay, that is highly basic. Okay, so fifth one, piperidine. Then comes third, cyclohexylamine. Then fourth, because pyridine. And then comes, wait, aniline, para-nitroaniline. Para-nitroaniline, nitro group which is an electron withdrawing. So that must be in your least one. Okay. So easily available lone pairs which will make large basic. If it is undergoing resonance, then the basicity will get decreased. In this question, the following half reactions are given. Fe3 plus and okay, copper tin. Their solution contains this one, and under these conditions, determine MnO4 minus can oxidize Fe2 plus to Fe3 plus spontaneously. Okay, so that's what the question is. We have to find the answer. So first of all, what is the cell reaction happening over here is with Fe. Let me write it over here. MnO4 minus plus 8H plus 5 Fe2 plus gives Mn2 plus 4H2O plus 5 Fe3 plus, right? So if you find out E naught cell value of anode and cathodic part. Look at the reaction. I have plus 1.51, and for Fe3 plus 2 Fe, that is plus 0.77. So substitute the values. 1.51 minus 0.77, it should be plus 0.74. Next, we have to substitute it in the Nernst equation. So while substituting in the Nernst equation, you have to put everything. Like E cell is equal to 0.74. I'm just substituting the value. This part you know. 592 divided by how many electrons are involved over here? Mn plus 7 state to Mn plus 2. So which means 5 electrons are involved, right? So divided by 5 log of what are the reactants? Mn2 plus and Fe3 plus are the products raised to the power 5, and MnO4 minus H plus raised to the power 8, Fe2 plus raised to the power 5. So now you have to substitute every values in this equation. Okay, so upon substituting you will get the E cell value. So that will comes out to be plus 0.67. Correct me if I'm not wrong. If I'm wrong, then what does the question says? Under these conditions, determine whether MnO4 minus can oxidize Fe2 plus to Fe3 plus spontaneously. And the option is talking about E naught cell value 0.74. Okay, cannot determine without an exact n factor in balanced cell, and E naught cell is 0.74. After Nernst correction, E cell is equal to plus 0.46. And the reaction is non-spontaneous. After the Nernst equation, I am getting 0.67, and reaction is non-spontaneous because this is more than the reverses of the cell. Okay, so reaction is spontaneous and it's more than 0. It's more than 0. Actually, it is less than 0. There must be a mistake in the question. It's less than 0. Or maybe I have done some calculation mistake. Okay, so you should get an E cell value as cost. Okay, sorry, it's more than 0. It's more than 0, and even after the Nernst correction, E naught cell is large enough. So which makes option A happen to be your right answer. Then starting from benzene, only an inorganic reactions the shortest route to synthesize 2-hydroxy-4-methoxybenzoic acid, that is 4-methyl salicylic acid. Okay, they have given the target molecule and asking you to consider these possible routes: benzene to toluene, and after that para-cresol via sulfonation, and Gold's reaction to form 4-methoxy-salicylic acid. And route B, route C, and route D are given. Okay, so which route would be possible to produce a 4-methyl salicylic acid? That's our question. So if you solve and the options are given as route A is correct, these are the options given. So these are the named reactions, or these are the important reactions you should know to answer this one. I think you already know these reactions. You can easily answer to this question. Okay, let me know what is the answer to this question in the comments.